Okay, so everybody go to your Schoology site, go to our courses, and we'll go to your section, either 4 or 6. And what I'll do is I'll have, everybody's, the days we're going to be doing stuff. Like tomorrow, you're going to be doing day 1. You'll click on that, and I'll have some kind of direction on the first part. And so you can see what we're going to do here. You can read through that. And so we're going to open this up, Universal Law of Gravitation Interactive, and you'll have to click this link. And this is the tutorial, so read through this. It gives you some background information, relates it back to Newton's second law that we've done. Some of the stuff's important, showing about the relationship between different units. Kind of a graphical thing there. You can go through that. I'm going to read through it. Some of this might not make a lot of sense to begin with, but after we go through this interactive and the notes this week, it'll become clearer, and we'll do practice stuff too. There's some practice problems you can go back to later on. As we start working some of the problems out, you can refer back to this. And we get all the way to the bottom, and we're going to do this interactive. There's some more stuff here that you can check yourself later for extra work. It'll show you how to, that gives you a problem and answers to that. It's always good to look at if you're confused about something. So click on the interactive, and you can read through the introduction here. And the activity you're going to do, it says view activity on your Schoology. It's this PDF down here. You'll click on that, and this will pop up. And that's what you're going to be filling all your information in. If you go down to the bottom, you can click gravitation here and click open it up again. And that'll give you on its own sheet by itself, not in. You'll click down here at the bottom where the PDF is blinking, and you can print this off. If you can't print it, then you're going to have to copy all this out, and you'll have to draw this picture, because what we're going to be doing on the interactive is drawing arrows on all these dots. And I'll kind of show you what I mean in just a minute when we go back to the interactive. So we're going to launch this interactive, and like we did before the other interactive we did with circular motion, you'll open this up and you'll have this page. Now you can move the moon wherever you need to, and you can see how the force changes. You can move the planet to wherever you need to, and you can see how the force changes. You can change with these sliders how much moon mass you have or how much planet mass you have. You can also show the planet's force too. So the first thing you need to do is move the moon over to the edge, put the planet right in the middle. So there'll be 3 squares on the top, 3 squares on the bottom, and there should be 7 full squares on either side. So 1, 2, 3, 4, 5, 6, 7, 8. So I need to move it over one more. And you'll have 1, 2, 3, 4, 5, 6, 7 on that side. So there's 7 on both sides. And what you're supposed to do is move this moon to where all the dots were on the PDF file that has the worksheet. And so the closest one is here. And you'll put it where that intersects that's where the first dot is. And I want you to lower the mass of the planet, lower the mass of the moon, increase the mass of the planet. And this actually, we're going to put it on 600 for the planet, and then make the moon let's see, adjust this a little bit. There we go. All right, so adjust it where the mass of the planet says 400 and the mass of the moon says 10. And then on your piece of paper, you're supposed to take a ruler and you're going to draw the force as it goes through the planet and draw it where the length of it represents that. And at the tip of the arrow, if you'll make a note of what the force says. And then you're going to go to all the spots that were on that. So if we go back to our PDF file, which is down here on the bottom, hopefully you've printed this out, you're going to move that moon to all those spots and draw the arrows and then record the force reading on that. And then once you've done that, you will go through and answer some of these questions. And then you'll go to this one where you're going to see the relationship that the force is on the moon and the planet by separating the distance, because you're looking at how the distance is being separated, if you double it, triple it, or quadruple it. And then you're going to do another one where you're going to take the mass of the moon and you're going to double it, triple it, and quadruple it, and see how that affects it. And then you're going to do the same thing with the Earth and do that. And then at the end, we're going to come up with a formula that has all those relationships in there using what we've looked at on this interactive. All right, so when we set this up, it takes a little bit to kind of get it going. So I'll show you what we did on Friday with the guys that were still in class. I guess we had about 5 in each class. All right, so let's go back to the interactive, open it back up again. And just remember, you're going to take this moon and put it to where all the different dots are and see, what happens. All right, so this one, we're going to take the planet all the way to the edge like this. As you can see, it's about 2 squares wide. That's the diameter. So the radius of the planet would be 1 square. And the first thing it asks you to do is put the moon twice that distance away. So there's 1 radius, and so the second radius would be right here. So you're going to put the first moon spot right here. And then we're going to, let's make sure it's right in the middle where all 4 corners kind of come together. So right in the middle, you got an X, you're going to be right in the middle. And so, I'm trying to think what we did. Now, I think we put it as high as we could go. And we wrote that as the force at twice the radius. So I'll go back and show you what I mean. So here's twice the radius. You're going to write that force in. And then you're going to move the moon to the next spot over. So it'd be 3 times the radius, and you keep going till you get moved it 12 times, and you're going to record the forces for all those. So here's the first one. Then you're going to move it here, then you're going to move it there, and then you're going to move it there. And you keep moving it 12 times, and you're going to write down what the force is for each of those. And once you've done that, you're going to use your numbers and figure out what happens. Does the force go down or up? And if it goes down or up, how much does it go down or up? You're going to have to use a ratio where you take the force that it was to begin with and divide it by the new force it has at that distance, either twice, 3 times, 4 times away. And it'll tell you what the factor is. You're going to round it to a whole number. And then once you do that, you're going to answer the next 2 questions where you've changed the mass of the moon. The first one, we're looking at the distance. The second one, you're going to look at how the mass affects it of the moon. And then you're going to do it again with the mass of the Earth. We can't decrease it by a factor of 4 on this one. So when you get to this one, you're going to have to kind of guess on what you think it would happen. By this time, you should see a kind of a pattern going on. All right, so when you get to this one, what we did is we moved this all the way down, and we moved this all the way down. And you see where it says force of 26? We moved this in such a way that we set it at a force of 10 newtons. And then we doubled this number and saw what the new force was. We tripled that number, wrote down what the new force was, and then we quadrupled it and wrote down what the force is. And we saw how that affected it. And then the last one, you're changing the mass of the planet. You're going to do the same thing. You're going to double this number using the slider, so it goes up a little bit. And then you're going to triple it. And then you can't decrease it by 4, but I want you to see if you can figure out what it should be. By this time, you should be able to tell what it means. What kind of relationship is going on. And then after that is done, you will go and write a conclusion. You're going to come up with a formula that solves for the F of gravity. So Fg is going to equal, and you're going to do something with the mass of the moon, the mass of the planet, and the distance between them. Quick hint, you may be able to look back at the tutorial reading that you're supposed to do before this, and that might help you figure out what's to go in this spot. All right, so you guys work through that, and we have office hours. What is it? 9:30 to 10:30, and 10:30 to 11:30, depending on which class you are. And just email me if you have any questions about anything. And then once you're done, I want you to, print this off, take a picture of it, and send that picture to email through Schoology, and I'll be able to grade that. All right, well, good luck on everybody. Hopefully you'll do fine on this, and then I'll send more of these videos out, giving you directions, or when we do a PowerPoint, or when we go over problems, I'll kind of do it this way, and hopefully that will work out for you guys. All right, talk to you later. Good luck. Hope everybody's doing well.